Hey there, everyone, welcome back for day 123 of me doing the NeetCode 150 challenge. So today we're doing another math and geometry LeetCode medium, and without further ado, let's get straight into it. Okay, today we get LeetCode medium problem 54, spiral matrix. Given an m by n matrix, return all elements of the matrix in spiral order. Oh boy. Okay. I think, was it on my birthday of the daily LeetCode challenge? I think I saw something like Spiral Matrix 2. And remember, my friend Noor did something like super clever that is like super simple. And that I did like this crazy, like, like always think of the direction you're going type of thing, blah, 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 blah. Okay. Okay, well, this is Spiral Matrix 1. So if we've solved something like Spiral Matrix 2 and they happen to be harder, then we should be able to solve this problem. It's just I remember solving that problem in a very convoluted way. Or actually... Right, actually, you can just start from the very first element. Okay, I guess I am going to solve it in my convoluted way, which is like I start with the very first element, and I say my direction is currently rightwards, right? And whenever it's like, I need to switch directions, I switch like, by 90 degrees clockwise. Until I either hit a border or something that's visited. Okay, I might as well do something like that. That's simple enough. M comma n is equal to length of matrix. Why is this math, though? Isn't this just like graph traversal? Like just okay. Is there like some super fancy way of doing this? Okay, I'll just do it this way. And then if anything, we can look at like the NeetCode solution. Okay. Here we'll say 0, 0 is equal to a set. Here we'll say right. Okay, so you want to go right. After right, you want to be able to go down. After down, you want to be able to go left. After left, you want to be able to go up, right? So this will be here we'll call this directions. And we'll make it clear that it's this, right? Right is 0, 1. Down is 1, 0. Yeah. Left is 0, comma, negative 1. Up is negative 1, comma, 0. Direction is equal to square and 0. Res equals this. Or here we'll say visited is equal to a set. I comma j equals 0, comma 0. Well, length of visited is less than m times n. Goal count. Yeah, sure. Then we'll say, okay. Here we'll start off with right. Is our grid at least 1 by 1? Yes. Okay. Now we'll say well, here what we want to say is I comma j. Yeah, basically I want next I next j. Yeah. Yeah, the only thing I can think of is of traversing, right? Next I, next j. I dj is equal to directions of direction index. Here we'll just say self dot this, self dot that. Here we'll have def get direction, return self dot directions of self dot direction index. Def turn self dot direction index plus or equal 1 self dot direction index modulo equal length of self dot directions. Turn right. Equals I plus direction equals get direction. Di comma dj plus dij plus dj. If def inbounds an I and a j, or here we'll just do inbounds. Oh yeah, here we can just make them like this, right? Here no reason to do this. Here we can say get direction equals lambda directions of direction index. Turn right equals lambda this one's about modifying something. Actually, I can make it swan update direction index or get new or update direction index. Get next modulo length of directions. There we go. Or you can call this next direction index. Equals lambda x comma y 0 less than or equal to x less than m and 0 less than or equal to y less than n. Right? If not inbounds next of I next of j or next of I comma next of j in visited, then direction index equals next direction equals this. There you go. Yeah, we don't need the magical functions. This is fine. Visited equals set with 0, 0, I, j. And here continue, right? And there's guaranteed to be at least something left because it's while length of visit is less than that, right? Otherwise, here we'll say visited that I comma j is equal to star index j dot add I comma j, right, and return list of visited, something like that. Comma length of matrix of 0, that's my bad. And that's the wrong answer. Why? Oh boy. Return j for I comma j in visited. It doesn't give it to me in the order. Okay. So ij. What does that append? Matrix ij. Return res. Okay, that works. Okay, yeah, it's just because the hash set won't have an order. Okay, so dictionaries in Python have an order. And there we go. Okay, 0 ms between 100%. There we go. Bada bing, bada boo. Okay, that's a nice thing to know. So hash sets don't preserve order in Python, but dictionaries, which are hash maps, do. Very cool. Okay, no worries. Nice. Okay, so yeah, here we have this and that. Here we have this will be used for direction turning. I comma j is equal to 0, 0. Here we'll just make it clear that it's 0, 0 that we're doing. Yeah. Goal count is equal to m times n, or count. Here we'll even say, well, length of res is less than this. Well, what are the values? They could be negative. Yeah, I can make it faster, but why make it faster? I already have 0 ms and might as well use a visited set. So yeah. Otherwise, yeah, ij equals that. Nice, okay. I can just submit one more time. And there we go. Bada bing, bada boom. We have a nice and efficient working solution. Okay, so as always, in all my videos, I do a quick recap if I was able to solve the problem. So for this one, this was one of more of those do this problems. So here was like, given a matrix, return it in spiral order, right? And the very first thing that I noticed is that, okay, we start off by going right? And we go right until we hit a wall, right? Here we hit a wall, and it's like, okay, this will be an out of bounds position. So what do? We turn our direction 90 degrees clockwise, right? We turn right. So here we're initially facing right. What's right of right? It's down, right? If you're going rightwards and you take a right, you'll be going down, right? So here I have the order, like, right. If you take a right from going rightwards, you'll go down. If you take a right, you'll go left. If you take a right, you'll go up, right? And if you take a right from that, you'll go right, and so on, etc., right? And so here's like you'll go from right until you can't, then you go down until you can't, then you go left until you can't, then you go up until you can't, and here we're not hitting a wall, we're hitting this one that we've already visited, right? So essentially, we'll keep going forward in a certain direction until we either hit a wall, right? Like for example here or here or here, or until we hit an element that we've already visited, right? Either case, we're like, okay, we have a hit like, you know, an impossible state, we need to turn right, right? And so like here, for example, this one's already visited, so we don't go there, we turn right into here, right? And we're gonna keep going until we've collected all the elements in spiral order, right? So we'll grab the whatever the count of elements is. So here I have n by n, m and n are is equal to length of matrix and length of matrix 0. So count will be n times n, right? That's how many total elements are in the matrix. So here I'll be like, you know, while my order is, while the length of my solution is less than count, I know I still need elements, so therefore I can keep expanding and I know I won't be stuck, right? And what I do is very simple. Essentially, I map out all my directions in terms of right, down, left, up, because that's the order they're in. And I'll have a current direction index that I'll use for getting my current direction, right? At the beginning, it will be 0 because at index 0, I have right? And it'll be convenient because to get the next index, essentially, I'll just add 1 to my index and then modulo by the length of directions, right? So essentially, like, you know, right, it's at index 0. Then at index 1, which is 1 more, it'll be like, you know, down, which is exactly what I want. If you're going right of that is down, right? Right of down is left. Right of left is up, right? The only thing is like when you're going up and you want to go right, you need to go back to right again, right? So that's why I do modulo 4, which is the length of directions, where it's like, okay, if I'm at index 3 here, right? 0, 1, 2, 3, index 4 doesn't exist, but that way when I do 3 plus 1, 4 modulo 4 will be 0, and I'll go back from up, down, back to right, right? So that's exactly what I want. So that's how I'm able to always get the next direction. Here I have a little inbounds function that just takes if coordinate is inbound, and then it's game over, right? So here at the very beginning, I'll be like, okay, we're going to start from 0, 0, so let's make 0, 0 visited. Let's put that as the very first element inside of my matrix, and let's use that ij as my current position, right? And here we'll say, okay, while we don't have count many elements, then here we'll say, okay, let's get the current direction, right? So here we'll do directions at direction index, and essentially it'll map to like, you know, how much I should change the row value by and how much I should change the column value by, right? So that's why I call them my di dj, and I'll say, okay, my next j will be I plus di and j plus dj, where ij is my current position, starting with 0, 0, right? And then here I'll say, okay, if the next I and next j is not in bounds or it's already been visited, then I know this is one of those scenarios where I must turn right, right? For example, here I kept going right until I hit a wall over here, and it's like, oh, okay, I need to turn right, right? So in those cases, I turn right, which I do by, okay, direction index will be direction index plus 1, and in case I'm going from up to right again, here I just modulo by length of directions to essentially keep cycling, right? And then here I'll just continue, because here I'll just like, you know, I'll have a new direction that I can essentially go, right? So here I'll have 1, then I'll go to 2, then I'll go to 3, and then here it's like, okay, I'll run through this, I'll update the direction index, and then I'll go back to 3, right? But here I'm going from 3, and instead of 3 trying to go right, now it'll be 3 trying to go down, right? So it's different. And then otherwise, like, you know, if this didn't happen, right, if I didn't need to change my direction, for example, let's say I'm at this 6, and they're currently down direction, then I'll say, okay, I and j is equal to the next I and next j, because I can actually get to it. I'll put that inside of my visited set as well inside of my solution set res, so that way I have the correct order of the spiral way that I'm going through, right? And at the very end of the day, all I'll do is return res. So I'm essentially traversing this grid in spiral order, right? I essentially start at 0, 0, and then I tell myself I'm going to keep going right until I can't. And can't is defined by either I go out of bounds or I visit something, I'm trying to visit something I've already visited, right? So that's why I keep track of a visited set, as well as, like, you know, always checking if things are in bounds, right? So initially I'll keep going right until I can't, then I'll keep going down until I can't, then I'll keep going left until I can't, then I'll keep going up until I can't, right until I can't, etc., 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 until I've exhausted all count many elements that exist inside of the matrix, right? And that's pretty much literally it, right? And this is just the logic in terms of, like, you know, turning right every single time. I have them in this particular order on purpose. I have my direction index that I'll modulo by 4 every single time I need. There you go, bada bing, bada boom. That's pretty much it in terms of how I was supposed to solve this problem. And yeah, so as always, let's make sure that we come over here and check out the fact that we did this problem. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate it if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.